Samsung Galaxy A54 5G camera test. Peace be upon you, my dear friends and followers of the channel. I hope you are well and in good health. Today with you is a beautiful, new and important video for everyone. But before watching the video, subscribe to the channel and like and share so that it reaches the largest number of people. Now let's follow the video and I hope you like it. We put the Samsung A54 5G through a battery of rigorous XMark camera tests to measure its performance in photo and video quality and zoom from an end-user perspective. In this video I will explain the device's performance in a variety of tests and several common use cases and aim to highlight the most important results of our testing through a snippet of captured data. Overview. Main camera specifications: primary camera, 50MP sensor, f/1.8 lens, DAF, OIS ultra-wide camera, 12MP sensor, 1.12A micro pixels, 123S field of view, f/2.2 lens. Big camera, 5 megapixel sensor, f/2.4 lens. Video, 4K at 30 fps. 1080p at 30/60 fps. Pros: good exposure and wide dynamic range in bright light and indoors. Decent detail in landscape shots. Autofocus is accurate and repeatable in most conditions. Cons: exposure and white balance instability. Focus errors in macro mode and scenes with moving objects. Unwanted artifacts, including halo effects, ghosting, and color quantization in high contrast scenes and on moving objects. Delay between autofocus locking and taking the picture when shooting handheld in low light. Samsung Galaxy A54 5G achieved average performance for a high-end device in our XMark camera tests. Still images were well exposed in good light without a lot of contrast, making the Samsung a decent choice for landscape photography. However, our testers noted white balance and exposure instability across successive shots, as well as a host of unwanted image artifacts, including ghosting and halo effects. Slow autofocus in low light was an additional limiting factor, making it difficult to respond quickly and capture moving subjects. About XMark camera tests: XMark camera evaluations are conducted in laboratories and in real-world situations using a variety of subjects. The results are based on objective tests, in which results are calculated directly by measurement software on our laboratory setup, and on perceptual tests, in which a sophisticated set of metrics allows a team of image experts to compare aspects of image quality that require human judgment. The smartphone testing involves a team of engineers and technicians for about a week. Image, zoom and video quality are scored separately and then combined into an overall score for comparison between cameras in different devices. For more information about the XMark camera protocol for recording and analysis, XMark engineers capture and evaluate more than 2,600 test images in controlled laboratory environments and in outdoor, indoor and low-light landscape scenes, using default camera settings. The photo protocol is designed with key use cases in mind and is based on typical photography scenarios, such as portrait, family and landscape photography. Evaluation is performed by visual inspection of images against a reference of natural scenes, and by performing objective measurements on chart images taken in the laboratory under various lighting conditions from 1 to 1000 plus lux and color temperatures from 2300 K to 6500 K. Exposure and color are the main features of technically good photos. For exposure, the main characteristic that is evaluated is the brightness of the main subject through different use cases such as landscapes, portraits or still life. Other factors evaluated are contrast and dynamic range, for example the ability to display visual detail in both light and dark areas of the image. Repeatability is also important because it demonstrates the camera's ability to provide the same view when taking multiple photos of the same scene. For color, the image quality attributes analyzed are skin tone rendering, white balance, color shading, and repeatability. For color rendering and skin tone, we penalize unnatural colors but respect the manufacturer's choice of color signature. Autofocus tests focus on focus accuracy, focus repeatability, shooting time delay, and depth of field. Shooting delay is the difference between the time the user presses the capture button and the time the photo is actually captured. This includes focusing speed and the device's ability to capture images at the right time. which is called no shutter lag capability. Even if a shallow depth of field can be pleasing for a portrait of a single subject or a close-up shot, it can also be problematic in some specific circumstances such as group photos. Both positions are tested. Focus accuracy is also evaluated in all real-life images captured, from infinity to close-up subjects and in low light to outdoor conditions. Texture tests analyze the level of detail and texture of objects in images captured in the laboratory as well as in real-life scenarios. For landscape shots, special attention is paid to the level of detail in the bright and dark areas of the image. Objective measurements are performed on chart images captured under different illumination conditions from 1 to 1000 lux and different types of dynamic range conditions. From 1 to 1000 lux and different kinds of dynamic range conditions. The charts used are the Special Excimark, DMC, chart and the Dead Leaves chart. Noise tests analyze different noise attributes such as density, color, granularity, and structure on real-world images as well as chart images captured in the laboratory. For natural images, special attention is paid to noise on faces and landscapes, but also on dark areas and high dynamic range conditions. Noise on moving objects in natural images is also evaluated. Objective measurements are made on chart images captured at different conditions from 1 to 1000 lux and different types of dynamic range conditions. The chart used is the Dead Leaves chart, and standard measurements such as visual noise derived from ISO 15739. The effects assessment addresses lens vignetting, chromatic aberrations, geometric distortions, edge ringing, halos, ghosting, quantization, and unexpected hue shifts, among other types of possible unnatural effects on images. The more severe and more frequent the effects are, the greater the points deducted from the score. Below is a list of the main effects observed and corresponding point loss. Preview tests analyze image quality in the camera app's preview of an image, paying particular attention to the difference between capture and preview, especially regarding dynamic range and bokeh effect application. Smoothness of exposure, color and focus adjustment are also evaluated when zooming from the minimum to maximum available zoom factor. Preview frame rate is measured using the global LED timer. Excimark engineers capture and evaluate more than 400 test images in controlled laboratory environments and in outdoor, indoor and dimly lit landscape scenes, using default camera settings and dial zooming at various zoom factors from ultra-wide to ultra-long range zooms. Evaluation is performed by visual inspection of images against a reference of natural scenes, and by making objective measurements of histogram images taken in the laboratory under varying conditions from 20 to 1000 lux and color temperatures from 2300 K to 6500 K. These tests analyze the ultra-wide camera's performance at several focal lengths from 12 mm to 20 mm. All image quality attributes are evaluated, with special attention paid to such artifacts as chromatic aberrations, lens smoothness, and distortions. The images below are an excerpt of the scenes tested. All image quality attributes are evaluated at focal lengths from approximately 40 mm to 300 mm, with particular attention paid to texture and detail. The result is obtained from a number of objective measurements in the laboratory and perceptual analysis of real images. Excimark engineers capture and evaluate more than 2.5 hours of video in controlled laboratory environments and in low-light landscape scenes, both indoors and outdoors, using default camera settings. The evaluation consists of visual inspection of natural videos captured in various conditions and running objective measurements on videos of histograms recorded in the laboratory under various conditions from 1 to 1000 plus lux and color temperatures from 2300 K to 6500 K. Exposure tests evaluate the brightness of the main subject and dynamic range. That is the ability to render visible detail in both bright and dark areas of the image. Exposure stability and temporal adaptation are also analyzed. Image quality analysis looks at color rendition, skin tone rendition, white balance, color shading, white balance stability and its adaptation when light changes. Texture tests analyze the level of detail and texture of real-life videos as well as graphic videos recorded in the lab. Natural video recordings are evaluated visually, with special attention paid to the level of detail in bright areas as well as in the dark. Objective measurements are made of graphemes taken at different conditions from 1 to 1000 lux. The charts used are Xmark, DMC, chart and dead leaves chart. Noise tests analyze different noise attributes such as density, color, granularity, structure and temporal aspects in real-life video recordings as well as videos of histograms captured in the laboratory. Natural videos are evaluated visually, with special attention paid to noise in dark areas and high dynamic range conditions. Objective measurements are made on video clips of histograms recorded at various conditions from 1 to 1000 lux. The scheme used is the Xmark visual noise chart. At the end of the video, I thank you for watching and I hope you liked it, and see you in a new video.